Lesson 2. We are going to be talking about something called points of discontinuity today. What that means is we're going to draw graphs just like we were drawing yesterday, but there will be a point on the graph that doesn't actually exist, but the graph still wants us to follow the trend. So it's like we approach that dot, but we draw an open circle there instead and then keep going, kind of like a bump in the road. All right, so we're going to find where those points exist. So here we go. Points of discontinuity. It's a point at which the graph of a function is not continuous. We have a little hole. It occurs in a graph of a rational function. So this only happens in graphs with rationals where it's a fraction, okay? And it happens when we can simplify the fraction by dividing the numerator and denominator by a common factor. So essentially, that's a fancy way of saying if we take our fraction and we factor the top and bottom, and if we can cross something off, whatever we cross off becomes the hole in our graph. Because it's kind of like it was part of the graph to begin with, but then we crossed it off, so it doesn't really exist anymore. That's what justifies a hole in the graph. All right. So the result of this is a single point missing from the graph, which is represented by an open circle, and that's sometimes referred to a hole in a graph, as I said. Okay. So that's really the only new thing we're going to do in this example. So for the functions below, determine the asymptotes, just like we did yesterday. The points of discontinuity, that's new. We'll determine the x and y intercepts, and we'll sketch the graph. We're going to create a table of values for any other points we need. And finally, we're going to state the domain and range. So we got lots to do. Okay, so to figure out if you have a point of discontinuity, that's always what you start with. Don't start by finding your asymptotes. Don't start with your x and y intercepts. Start by seeing if you can factor this fraction, okay? So what we do then is we say, okay, well, I can factor the top, y equals x, x plus 2. I just factored that common x out. I can factor the bottom, difference of squares, x minus 2, x plus 2. Now I can cross those off. So I have just simplified my fraction, right? Easy enough. So my new function or my new equation is just this guy. And this is what we will use from now on because it's way simpler. Got it? Following so far? Now, the point of discontinuity comes from whatever was crossed off. So what you do is you take what was ever crossed off and you set it equal to 0 and solve. So that means at x equals -2, we have a point of discontinuity at x equals -2. So we'll have a hole in the graph there. But of course, any point comes from two coordinates, an x and a y. So let's figure out where the y is in that case as well. That makes sense? So all we do is take our x equals -2 and plug it into our equation. And remember, you can use this one now, it's simplified. If you plug in -2, just figure out what y equals. So y equals -2 over -2 minus 2. And you simplify that, that's -2 over -4, that's 2 over 4, that's 1 over 2, that's 0.5. So we have a point of discontinuity when x is -2 and y is 0.5. So we know when we draw the graph, we'll draw an open circle at that point. Because it's like it was there to begin with, but we kind of deleted it, but it's still kind of there. You know what I mean? Yeah. So we call it a hole in the graph. Okay, so now that we've done that, let's move on and do our asymptotes. So this is what we did yesterday. I'll start with my vertical asymptote. Vertical asymptote is the easy one, the one we don't stress about. It's just our denominator set equal to 0. Once again, you're not using him. You're using him from now on, okay? So x minus 2, set that equal to 0. We have a vertical asymptote where x is +2. Okay, now horizontal asymptote is the one that we sometimes stress about because there's the two options. But if I don't specify what option you have to use, you can use the easy option from yesterday, and that's one where you just compare the degrees, right? So if you compare your degrees of your x's, that's a 1, that's a 1, they're tied. When they're tied, you just divide the coefficients. 1 divided by 1 is 1. So I have an asymptote at y equals 1 because my exponents are tied, if you want to write that in. Okay, so I've got my point of discontinuity. I have my x and y I have my asymptotes. I still need my x and y intercepts. That's what I'll do next down here. Okay, so my x-intercept, I take that equation, the simpler one, and plug x in with 0. Now remember, whenever you have 0 on the left and you have a fraction on the right, what you'll always do is multiply each side by x minus 2. It's important to know this because it's going to come back later. So really, those are gone, but your left side still remains 0, right? So it's kind of like this denominator just doesn't exist when you find the x-intercept. It just goes away. So you have 0 equaling whatever the top is. 0 equals x. So my x-intercept when y is 0, x is 0. I'm going through the origin. Y-intercept, I'm going to take y equals, I'm going to plug x in with 0 in that easy equation. Well, that also ends up being 0 over negative 2, which is just 0. So my x-intercept and my y-intercept are the same point. So even though I did the work to find 2 points, I actually only found 1 point there. Yeah? And I said you have to have 2 on each curve. So we're going to have to find some other points. But for now, we're going to go in and we're going to draw what we all have. So the first thing I'm going to do is draw my asymptotes in. So I have a vertical asymptote at x equals 2. I have a horizontal asymptote at y equals 1. Okay, now let's plot the points that I have. Well, I know I have an x and y intercept shared at the origin. And I have another point as well. You're going to plot your point of discontinuity. Key matters, okay? So negative 2, 0.5 is there, but you're going to draw it as an open circle instead. And remember how I said yesterday you need 2 points on each curve? Well, you have your 2 points. This open circle still counts as a location on your curve, okay? So all you do is you connect and you just kind of skip your line over top of that hole in the graph, trend towards the asymptotes, and you're done. Now the problem being we don't have any points on our other curve. So just like yesterday, I'm going to create a very quick table of values, and I'm going to choose 2 values of x that exist underneath that quadrant. I'll just do 3 and 4. You could use 5, of course. Okay, and I plug those into my easy equation. So 3 over 3 minus 2 is 3 over 1, which is 3. And 4 over 4 minus 2 is 4 over 2, which is 2. Okay, so I plot those 3, 3 right there, 4, 2 right there. I have my 2 points, curve, trend, done. So that's how we deal with points of discontinuity. Now, domain. Yesterday when we dealt with domain, it was just whatever your asymptote was what your domain couldn't be, right? So we cannot be equal to 2, but we have an additional domain now. What else can't we be equal to? Negative 2. Because of that open circle, we're not actually going through that. That makes sense? And then for all of the other values, we know those are real numbers. So you can just tack that on the end. And range, same thing. My y value, I can't be 1 because of the asymptote, but I also can't be 0.5 because of the hole in the graph. And the other values are real numbers. And we're done. I'm just, yeah, when it's, yeah, that's fine. I don't like it. It's fine. Mathematics, like it just, because it's like plus or minus could be plus or minus. It's plus and minus. Okay, it's both for sure. Okay, moving on. Okay, so we've gone over points of discontinuity. It's pretty simple. We're going to just pause from that for a second, and we're going to look at 2 examples that are just weird. These are unique circumstances where the asymptotes are funky and weird shit happens. Okay? So for this example here, it's still the same instructions. I still ask you to do all of the same things. So the first thing we do is to check if there's a point of discontinuity. I'm telling you there's not. And the way we know is always by trying to factor and see if we can cross off. The problem is I can factor the numerator. I cannot factor the denominator. That is not a difference of squares. So I cannot cross anything off. We tried, but we can't. So we ignore that work we just did, and we know we have to use that original guy, and we know there are no holes in the graph because nothing got deleted. So no points of discontinuity. Okay, so let's do our asymptotes now. Vertical asymptote is always your denominator. You take your denominator, we don't stress because this is the easy one, and we set it equal to 0 and we solve, but now I'm stressed. Why am I stressed, Gage? I can't root a negative. That's impossible. There is no vertical asymptote. Listen, when there is no vertical asymptote, that's when weird stuff will happen. So weird, in fact, I'm not going to make you draw them, okay? Because you would have to do a table of values with 20 values on it to figure out the trend of the graph because it's so bizarre. I'm going to show you what the graph would look like. But just understand, if you ever run into a case where there is no vertical asymptote, you don't have to draw it. You still have to do all the other calculations it asks for, but you don't have to draw it. And in the textbook, you can just look at the back and look at the graph and be like, oh, that's weird, but you don't have to draw it yourself. Okay? Let's see what happens with the horizontal asymptote. Horizontal asymptote, let's do the easy way. Let's compare our denominators. If we look at my two denominators, the bottom degree, or sorry, my numerator denominator. If I look at my 2 degrees, the bottom one is bigger. If you go back to our notes yesterday, when the denominator is bigger, there is immediately an asymptote at y equals 0. Remember, you have to memorize those, okay? All right, let's find our x-intercepts and our y-intercepts. Let's keep rolling. Okay, do you remember what I said about x-intercepts? If you plug 0 in and you have 2x plus 4, I don't even care about the denominator because we're going to multiply both sides by it anyway. It's going to cancel out and disappear. So you can just say 0 equals the numerator minus 4 to 2x divide by 2. You have negative 2 equals x. So I know I have an x-intercept at negative 2, 0. Y-intercept, I have y equaling 0 plus 4 over 0 plus 1. It's 0 squared, doesn't matter, it's still 0. And I get y equals 4. So I have a y-intercept at 4. Okay, we're going to draw this. Again, like I said, you don't have to draw these in real life or on an exam or in your assignments, anything like that, because we have no vertical asymptote, so weird stuff's going to happen. I do have a horizontal asymptote, though, so I can at least draw that in at y equals 0. Okay. So we know some points. We know that I have an y-intercept at 4. What's weird about my x-intercept? It's on the asymptote. That's new. Okay. So we have a 4 up top, my intercept. We have a negative 2, my intercept. And if we were to do a giant table of values to find a whole bunch of other points, this is what the graph would look like. Okay, so that's why you're not going to draw those. That's weird. We're not used to that. So this is what's going on here. Okay, we have an asymptote, right? But on this side of the graph, the left side of the graph, it's like the line just doesn't give a shit. Okay? It's like, I don't care. I'm going right through that asymptote. I don't care. Screw you. I'm doing it. But then on the other side, we have a well-behaved graph who does listen to the asymptote. Okay? So sometimes you're going to run into a situation because rational functions are a fraction, right? And fractions are made up of two parts, right? So it's kind of like one part is listening to the asymptote and one part isn't. It's like the asymptote is only being applied to one part of the function. So the asymptote is being applied to this guy. It's well behaved, but over here, this function doesn't need to listen to the asymptote. It's hard to wrap your brain around, but it's kind of like a two-headed dragon or like a devil on your shoulder and an angel on your shoulder. One's good, one's bad. That's going to happen sometimes, okay? So again, I'm not going to make you graph those. You don't have a vertical asymptote. Weird things happen. The graph's all over the place. But I do expect you to still do these calculations here, which are easy enough. Okay? That's one weird, unique example. Let's do another weird, unique example. This guy here. Okay. So the first thing you're going to check is, yes. Oh, did I not do that? Pardon me. Forgot. Okay, domain and range. Now, does this graph span every value of x? Does it ever stop left or stop right? No, it goes left forever and it goes right forever. So your domain is an x is an element of reals because that makes sense. You don't have an x-intercept or sorry, asymptote. Okay. Your range though, your range is usually affected by your horizontal asymptote, right? We're saying like y cannot be that, but that graph doesn't care. It plows right through it anyway. Okay, so you will not say that y can't be equal to 0 because it can. It is. It's doing it anyway. Okay, it's also not real numbers because it stops at 4, right? That's as high as it goes. So your range here would be y is less than or equal to 4. That's your max. It's almost like a parabola that got drunk. Okay, so it started at 4, went one way, the other way, and your other numbers are an element of reals. What was that, Connor? A parabola on Fent. Connor, everyone on the video is going to hear that for all the years to come. It's Connor Gabriel, everybody. Okay. Okay, let's do another weird one. Okay, so the first thing you're going to do is, can you find points of discontinuity? Can I factor the top? No. If you factor the bottom, it's x minus 2, x plus 2. You won't be able to cross anything off, so I'm not even going to write it. I have no points of discontinuity. I can't factor and cross off, so this is the guy we're stuck with, okay? Let's go on to our asymptotes. A vertical asymptote, I don't stress. I just take the denominator, set it equal to 0. I solve. I put 4 over. Why is this a unique situation, you think? Because you have a plus or minus. Very good. X equals plus or minus 2. So you have an asymptote at 2, and you have another asymptote at -2. We have 2 vertical asymptotes. Weird. We haven't seen that yet. Okay, let's do horizontal. Horizontal, just do the easy way. If I don't specify, compare your degrees. The degree on the denominator is bigger. When that happens, you immediately have an asymptote at 0. We have 3 asymptotes, 2 vertical, 1 horizontal. Okay, so again, this is weird. The next part of the question said to find your x and y intercepts, so that I will do here. Again, if I make y equal to 0 and I recopy my right-hand side, I know my denominator will disappear. If I multiply both sides by x squared minus 4, it'll cross off on the right and still be 0 on the left. If I solve for x, I just have 0. Okay. And my y-intercept, I would have y equals 0 over 0 minus 4. That's 0 over -4. That's still 0. So in this scenario, again, my x and my y-intercepts are the same point. They're both at the origin. What do we know about the origin? There's going to be an asymptote going through there because I have an asymptote of y equals 0. So again, we have points just breaking the rules. Okay? Let's draw this out and see what happens. Okay, asymptote at +2, asymptote at -2, asymptote through the center. Now, I wrote a little note for you underneath. It says, in between two asymptotes, so that would be the center section here. In between two asymptotes, you need to find 3 points. The reason for that is when we have a graph that exists between two asymptotes, it can look one of 4 ways. It can be a parabola pointing up or down, or it can be one of those fun curves pointing left or pointing right. It can be any of those 4 shapes. So you have to find 3 points to really know what the trend is of that shape. Okay? Then for graphs like this, when you have multiple asymptotes, you only need to find 1 point on the outsides of the single asymptotes, okay? So because there's so many asymptotes going around, I'll take it easy on you. You only have to find 1 point for the curve over here and 1 point for the curve over here, but 3 for the center. Now, the only point I know is that one. That's the only point. That was my X and my Y intercept. That's all I know. And it's breaking the rules. It's on the asymptote. So we know we have weird stuff going on, right? Now, I just told you, you need to have 3 points in here. So I need to find 2 more. So I'm going to pick some X values and create a table of values. So I think it would be smart to choose an X value to the left and an X value to the right, a -1 and a 1. Okay. But I also need to find 1 point on this side. So maybe I'll choose -3. And I also know I need to find 1 point on this side. So maybe I'll choose +3. So I have 4 points to figure out. So I'm going to create a table of values. And I think I left you guys space down here to do that. But I'll do it right here. I'm going to create a table of values with those 4 X values I just said. The -1 and the 1, those are the ones for my betweens, okay? And then -3 and 3, and those are my singles. Okay? Then you take your equation. The equation we're dealing with is 2x, x² -4, and you go and you plug each of those values in and solve. I'll do that work for you just to save some time. When x is -1, y is 0.7-ish. When x is 1, it's -0.7-ish. When x is -3, it's -1.2. And when x is 3, it's +1.2. Okay, so let's plot the in-betweens first. So -1 and 0.7. So I'm going to tack in that this is my 1 and my -1 for my y. Spread them out nice and big. So -1 and 0.7 would be about there. Okay, right there. And then my other one is when it's +1, it's -0.7. So now I see which of those 4 options it is. It's not a parabola, right? It's one of those snakes. Tan graph, kind of, right? Remember those? Remember chapter 5? What fun. Okay, now let's do the singles. So when x is +3, it's 1.2-ish. And when x is -3, it's -1.2-ish. We're not between two asymptotes anymore. We're singles. So when we're singles, we're just that curve that we've been doing the whole time, okay? And these curves, bottom left and top right, always trend the same way, okay? You got a curve going that way, you got a curve going that way, you trend, and that's how you'd graph something like that. That's another unique situation. You have to be able to graph these, absolutely, because you have verticals. It's only when you don't have verticals, okay? Now, domain and range, sorry. Domain. Can my x be absolutely anything it wants? No. So remember how I said we kind of have two functions coexisting here? Sometimes the asymptote applies to one, but not the other. So it's like these two little curves are listening to the asymptotes, right? So the asymptotes apply to them. But this guy is only listening to these two. He's not listening to this one. So you'll see that happen sometimes, and that's okay. But for the domain and range, you look at the whole graph as a whole. Your domain, x cannot be equal to -2. X cannot be equal to 2. We don't ever cross those asymptotes, right? All right. And your range, we go up forever and down forever because of that middle guy. He's completely bypassing that asymptote. So your range is everything because that one graph is just not listening to it. Let's do another unique situation. This is where we don't have any asymptotes at all. I know, I'm almost there. We're going to be done. We're going to be done soon. Almost done. This is the last graph, and this one's so easy because what do I always say you have to do first? Check your points of discontinuity. See if we can simplify this guy a little bit. I'm going to change that y equals f of x to a y. Same thing. I can factor the top to x plus 3, x plus 1, and I can leave the bottom of x plus 1. And look at that. We have a point of discontinuity again. We're going back to that. So now that we've simplified this equation, my equation that I'm going to graph is y equals x plus 3. You learned how to graph those in grade 9. That's y equals mx plus b, right? You have a slope, you have a y-intercept. Understood? Okay. Vertical asymptote. We don't have a denominator, right? So if we don't have a denominator, you don't ever have a vertical asymptote. Okay? Horizontal asymptote. We don't have one of those either because it says we have to compare the numerator and we don't have one. We can't compare. So none. Got it? Okay. My x-intercept very quickly, because it asks us to do that in the instructions. Set y equal to 0, 0 equals x plus 3. You have a x-intercept at x equals -3. Your y-intercept, don't do any work. We know that y equals mx plus b gives us the y-intercept, which is the b value. So y equals +3. So we've gotten everything. No, we haven't. Pardon me. We have not figured out where the point of discontinuity exists. Okay, we're going to have a hole in the graph. So the point of discontinuity exists with what value I crossed off. So it exists at x equals -1. Do you understand why? Because if I were to plug in a -1 for my x values, these would become 0 and 0, and the whole thing would just become 0. So that's why we have like a 0 at that spot or a hole in the graph, okay? So x equals -1, and then I'm going to plug that into this guy to figure out my y. So -1 plus 3, y equals 2. So I have a point of discontinuity at -1, 2. So I have a whole bunch of points. I have an x-intercept, a y-intercept, and a discontinuity. Let's quickly draw this. Now, you might say, oh, we don't have to draw this one because it's a vertical asymptote, but it's just a straight line. Right? There's no horizontal asymptote either. This is a very basic graph. So it's only when you're just missing a vertical. Okay, but you still have a horizontal. Those are the ones you don't have to draw. Okay, intercepts. I have one at x equals -3. I'm just going quick here. I have one at y equals 3. And then at -1, 2. So about there, I have a discontinuity. Connect. I know it's linear. And you're done. Now, the domain and range of a straight line is usually just x and y are an element of all real numbers, but because of that discontinuity, no, we have something we have to add in. So your domain, x cannot be equal to -1, but it can be everything else. And your range, y cannot be equal to 2, but it can be everything else. So there's another bizarre circumstance. We're going to finish with two very simple examples. We don't have to graph these. I just want you to write the equation. So I give you some random information here, number 2, and I want you to write a possible equation, okay? So all I tell you is that I have a point of discontinuity at -4, -6, and I also tell you the x-intercept is 2. So if I have a point of discontinuity at -4, it's telling me x is -4. So that means at one time, though, it was x plus 4. Understood? That's the factor I crossed off. That's how we get points of discontinuity. It's whatever we crossed off, whatever factor we crossed off. So that means if I cross that guy off, I know that my original equation had an x plus 4 up top and the bottom, because it's what I crossed off. There has to be one top and bottom. You good? Now the next thing says there's an x-intercept at 2. Any guesses what I would add in to represent that? X minus 2. Very good. Because imagine that these really aren't here. They really aren't there, right? They would get crossed off. So then the x-intercept, you would just have 0 equals x minus 2 left. So that's how you get the x equals 2. And that's it. We threw in those pieces of information, we move on. That's a possible equation. You don't even have to multiply it out. I don't think the textbook does. They just leave it like that. Okay, next one. This one, I tell you, you have asymptotes at 4. So that means that's a vertical asymptote. And that means you have 2 of them. You have 2 verticals. Your vertical asymptotes come from your denominator, right? So that means our denominator at one time had an x minus 4 and an x plus 3 in it, because I set both those factors equal to 0. That's how you get your vertical asymptotes. So I've taken care of that piece of information. Then it tells me I have an x-intercept at 0. So what do I have to add in to represent that I would have an x-intercept at 0? Anything? What would be on top? Yes. Oh my God, you guys are smart. Just an x, because an x-intercept is where I plug y in with 0, right? If I plug y in with 0, what would I have done? I would have multiplied both sides by the denominator, which would make the denominator go away. So if my denominator is actually gone and I have a 0 on the left, I want 0 equaling x. I don't want any extras in. So that's all you would do, and that's done. Okay? Okay, so that is that. I know that was a lot. You guys still have 28 minutes. We didn't do bad. There's the assignment there, and this won't be due till Monday, right? Yeah, Monday. Tomorrow we do the last lesson already. Remember, Monday is a work period for you to do what you got to do. If you want to do a review, I'll give you some questions, but I'm not taking that in. Yeah? Yes, Miss Wolf. Sounds good, Miss Wolf.